Here are solutions to homework set number 9 for ECE 111. This homework looks at problems you'll encounter in Circuits 1, EE206. How to solve those using Matlab. Well, with Matlab, you're able to solve n equations and unknowns really easily as long as you use matrices. Matlab is a matrix language, and with matrices, problems like that are actually fairly easy. The challenge then is, how do you set up a problem so that you can solve it using n equations and unknowns and matrices like Matlab? So the first problem looks at a resistor network, something that you'll see in Circuits 1. What I want to do is solve for the voltages V1 through V5. To do that, since I have 5 unknowns, if I can write 5 equations for 5 unknowns, I can solve using Matlab. Starting out, in problem 1, we use a thing called voltage nodes. With voltage nodes, what you do is you assume the voltage at each node, that's what I want to find. The voltages are where the currents balance. So at node 1, I have current flowing left, down, and right. Conservation of current says these currents have to add to 0. So the equations are going to be V0 equals 10, that's my voltage source. At node 1, the current left is V1 minus V0 over 50. The current down is V1 minus 0 over 200, and the current right is V1 minus V2 over 75. Those three have to add to 0. At node number 2, the current left is V2 minus V1 over 75 plus V2 over 300 plus V2 minus V3 over 125 equals 0, and so on for nodes 2, 3, 4, and 5. There's a trick you can use to check your answers. When I write these equations, at node 1, all the V1s are positive, everyone else is negative. At node 2, all the V2s are positive, everyone else is negative. That's a quick way to check for sign errors. So that's the first part of the problem. Give me n equations for n unknowns. To solve, that's where Matlab comes in. What I want to do is rewrite the equations in matrix form. So if I group all the terms together, the first equation is V0 equals 10. The second one, I've got minus V0 over 50. All the V1s, I have a plus V1 over 50, V1 over 75, V1 over 200, and minus V2 over 75. There's the first equation rewritten. Likewise, at node 2, at node 3, node 4, node 5. I can now put that in matrix form. So in matrix form, here's what she looks like. What I like doing is just putting some notation to myself. The first column, here's my unknown voltages. This is times V0, the first entry. This one is times V1, times V2, V3, 4, and 5. That's just a reminder myself when I write out the equations what they represent. The first equation, V0 equals 10, in matrix form is 1 times V0, nothing times anyone else, is 10. The second equation, minus 1/50th V0, is this term, plus that mess times V1, minus 1 over 125, wrong equation, minus 1 over 75 times V2 equals 0. Third equation, minus 1 over 75 times V1. This mess times V2 minus 1 over 125 times V3 is 0, and so on. I now have this in matrix form. I could say this is equal to A times X equals B. X is just the inverse of A times B. So in Matlab, I guess call that B and A. B times X equals A, X equals B inverse times A. So input this matrix into Matlab, and this is kind of a big matrix, so what I did is, here's the first row, second row, third row, fourth row, dot, dot, dot. Pack them all together, there's your B matrix, A matrix, and now the solution is the inverse of B times A. I just solved 6 equations for 6 unknowns. I can check my answer by going to Circuit Lab, build the circuit, and solve, and if you notice, I have the same answers. And they should be the same. This is really what Circuit Lab is doing. It's iterating, trying to find out what voltages make the currents balance. So that's one way to solve circuits that you'll be covering in 206 Circuits 1. Set up the problem as n equations and unknowns. There's another approach called current loops. If I take a voltmeter, take the leads and shorten together, I get 0 volts. If I go around a closed path, wind up where I started, I should wind up at 0. So with current loops, what you do is I look at each window to find a current in that window. I like drawing the currents clockwise. Now around any closed path, the voltages have to add 0. So if we go around this path I1, I get the minus sign first, so that's minus 10, plus this voltage, that's I times R, 50 times I1, plus this voltage, that's I times R. I've got the current coming down, so that's I1 minus I2 times 200. And I'm back where I started, equals 0. Around loop I2. I'm now going up, so this voltage, which is 200 times the current going up, I2 minus I1, this term, plus 75 times I2, plus this voltage, that's 300 times the current going down, 300 times I2 minus I3 equals 0. Repeat for nodes 3, 4, and 5. And there's a pattern here. If you make all the loops go clockwise, as they go around loop I1, all the I1s are positive, everyone else is negative. Around loop I2, all the I2s are positive, everyone else is negative. That's a quick way to check for sign errors. When I'm done, I have 5 unknown loops. If I can write 5 equations for 5 unknowns, I can solve. And these are my 5 equations. In Matlab, I can now solve. If I take the equations and group the terms, I can then put that in matrix form. So here's your B matrix, here's X, here's A. The B matrix would be this equation, put in matrix form. And again, what I like doing is the way I wrote the currents is I1 through I5. So this is times I1 times I2, I3, I4, I5. The first equation's 250 I1, which is right here, minus 200 I2 is 10. Second equation, minus 200 I1, let's do it this way, minus 200 I1 plus 575 I2 minus 300 I3 is 0. And so on, third, fourth, fifth equation. Throw that in Matlab. So here's my B matrix. Here's my A matrix. Here I did the first row, second row, third row, ran out of space, called it good. Take the previous answer, add to it, the fourth row, fifth row. You'll somehow input this into Matlab. Here's my A matrix. Then the current is the inverse of B times A. And I multiply by 1,000 to give units of milliamps, just because the currents are pretty small. I can then check my answer. Throw this into Circuit Lab. Click on the left side of the resistor, and that'll tell you the current going this way. That's I1. Click on the left side of the resistor. That's your I2, I3, I4. So these are the currents. And if you notice, the currents match up with what Matlab calculated. That's one way to check your answer. Do your calculations, build the circuit in Circuit Lab, and your answer should match up. That's homework set number 9 for ECE 111, solving n equations and unknowns in Matlab. Specifically, doing current loops, voltage nodes, problems you typically encounter in Circuits 1.